Okay, this video is going to be about the metric system, and before we kind of get into it, we should talk about what the point of the metric system is. There's really two valuable points for the metric system. The first one is that it's considered to be a universal system, which means all countries use it. That's not exactly true. The United States doesn't do a very good job of using it. We like to use it when we want to compete and make money, but other than that, we don't use it as well as we probably should. We do use it in science. That's why you always learn about it in science, because our scientists want to be able to talk and communicate with all other scientists around the world, and they're not going to be allowed to unless they are using the metric system. So the metric system is used fairly worldwide. The most important part about the metric system, though, is that it's base 10. That it's all based on the number 10, which makes math very easy because we can just move the decimal to the right or the left based on what the prefix is. So if you look on here on this chart, basically it all comes down to these prefixes. And normally we kind of have you look from kilo down to milli. And we have you try to memorize these. But I'm going to look at some of these other ones here too as we go through here. We always have a base word, so somewhere right in between deca and deci here, we'll have what we call a base, and this can be any kind of a base word. Normally, what you see in science is that we're using the gram if we're talking about mass. We use the meter if we're talking about length, and if we're talking about volume, we talk about the liter. But I could put any word in here I want to. We could put cats, and we could talk about decacat, which would be 10 cats. So all it matters is the prefix that's on the front of the word. That means how many of that word you have. So if I have deca on the front of gram, that means I have 10 to the first, or 10 grams. A hectogram, hecto starts with H, that's an easy one to remember, because so does 100, or 100. A hectometer would be 100 meters, and then a kilogram would be 1,000 grams, or a kilometer would be 10 to the third, or 1,000 grams, or meters, or liters, whatever you're putting it on the front of. When we go below the base, sometimes students have a little bit more hard time with this. We have deca, centa, and milli, and this is 10 to the minus 1 power, which means a decimal. So we have 0.1, or of course that means 1/10. We have 0.01, or 1/100th, and we have 0.001, which is 1/1000th. So if I have something that's like 1 millimeter, that means then the milli is 1,000. So the milli, instead of a milli, I write 1,000, and then I write the meter. So a millimeter is 1,000th of a meter, which means there would be 1,000 millimeters in 1 meter. So it's very valuable for you to remember these conversions and keep these straight. To remember these first 6, usually we have a little phrase that we use. There's a couple different phrases you can use, but I'll do King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk. So we have kilo, hecto, deca. And then the reason I like this phrase is because it uses the B, which of course stands for the base unit. So it could be gram, meter, or liter. King Henry died by base, deca, centa, and milli. So that's one way you can remember these 6 in here. We do want to look at some of these other ones here, and you'll notice that after the kilo, so we went up by tens, 10, 100, 1,000. But then after kilo, we jump by thousands. So kilo, there's 1,000 kilos in a mega, and 1,000 megas in a giga, and so on. And likewise, when you get down below milli on this chart, we start dividing by 1,000 each time, rather than just dividing by 10 each time as we were doing. we start going down by thousands for micro, nano, pico, femto, and so on. Okay, so I think that'll be a basic structure for you there. What I'd like to do now is to kind of go through each of these, and we'll just choose the meter as our base unit, and then kind of look at various sizes of things based on the meter and the prefixes that we have. So the first thing we'll look at is just a standard meter. See what we have here, and of course the meter. The meter's right in here. It's going to be our base between the deca and deci. A meter, the way you kind of think of what a meter is, it's usually basically the height of like a 5-year-old, an elementary student, is about a meter. Most adults are under 2 meters. Of course, Shaquille O'Neal is ginormous, and he's about 2.1 meters tall. He's a giant. So a lot of times we try to think of things that we can use quickly to measure a meter on like our bodies. And on your body, if you try this out, if you put the end of the meter stick on your right at the end of your right shoulder, and then hold out your left arm, then it's not very good. But anyway, from this shoulder over to the wrist on your other arm, that is about a meter. So you can try that out sometime. Get a meter stick and put it on your one shoulder, put out your other arm, and go over to the wrist of your other arm and see. And that should be, most humans, that's almost perfectly a meter. So that's kind of how we can find a meter somewhere on our body to measure. Okay, so that's what we're going to based on the meter. So we're going to look at these different things here. We're going to, if we have a decameter, which would be DAM, the abbreviation, 1 decameter. Deca means 10, so that would be 10 meters. So if I take 10 meter sticks and lay them end to end, I'll have what we call a decameter. That'd be about like 5 Shaquille O'Neals laid end to end. If I have 1 hectometer, H is an easy one, it stands for 100. So 1 hectometer would be 100 meters. I'd take 100 meter sticks, line them up end to end, and I would have a hectometer. A kilometer, 1 km. Kilo means 1,000, so that would be 1,000 meters. I'd take 1,000 meter sticks, line them up end to end. I'd have a kilometer or a kilometer. We kind of pronounce that 2 different ways. Let's look at a kilometer a little bit more detail. A kilometer, 1 kilometer. A lot of you are used to miles, so what is it in terms of miles? It's a little over half a mile. A kilometer is a little over half a mile. To be exact, it's more 0.621 miles. It's like 0.6 of a mile. So for a kilometer. This building here is the tallest building in North America. It's in Chicago. It's called the Sears Tower. And from the top of the antenna all the way to the bottom of the building is about a little over half a kilometer. It's like 527 meters. So it's a little over half a kilometer tall. So if I took 2 Sears towers, stacked them up on top of each other, I'd have about a kilometer. In the Army, they use a term called clicks. You say you marched off 10 clicks. That actually is just a slang term for a kilometer. So just thought I'd throw that out for some bonus information. So a kilometer is 1,000 meters. It's a little over half a mile for a kilometer. Okay, so that takes us up to a kilometer right there. I do want to go up one more. We're going to jump up 1,000 up to what we would call a megameter. And so now we're talking about 1,000,000 meters. So we're going to look at something pretty big here. 1 megameter is 1,000,000 meter sticks lined up end to end. Or 1 megameter would equal 1,000 kilometers. So when we're talking about this, we're gonna have to talk about like the radius of the Earth. So I could measure the radius of the Earth out here, and that happens to be, I'll kind of round it off a little bit, but basically 6.4 megameters. So 6.4 megameters, that would mean that the radius of the Earth is like 6,400 kilometers, or 6,400,000 meters to the center of the Earth. So we're talking pretty big. A megameter is a pretty big thing. It's 1 million meters right there. Whoops, that's a billion. That's a giga right there. There we go. That's what we want. That's probably confusing. So, right there. There we go. Okay, so that's a megameter. Let's go down to the other end now. So we got down to milli. We're going to go down, or here's meter, and we're going to go down below that to decicenta and milli. Let's go down there. So if we look at those, and we'll try to look at all those at kind of the same time. A decimeter, 1 decimeter. Deci means 1/10 or 0.1. It's right here, 0.1, 1/10. So it'd be 1/10 of a meter, 1/10 of a meter, which means there would be 10 decimeters in 1 meter. And the way we usually measure a decimeter is it's basically the width of your hand. Think of the width of your hand as about 10 centimeters, or 1 decimeter, or a tenth of a meter stick. So that's a decimeter, 1/10 of a meter. Let's look at a centa. 1 centimeter equals, centa means 100th, so 100th of a meter. That's an easy one too, because you can always think cents. How many cents are in a dollar? Well, there's 100 pennies in a dollar, 100 cents in a dollar. There's 100 centimeters in a meter stick. 1 meter would equal 100 centimeters. And therefore there's 10 centimeters in 1 decimeter. So there'd be 10 centimeters across the width of your hand. And the way we figure out about a centimeter is it's about the width of your pinky. If you take your pinky and you put it on a ruler, you're going to see that it's about 1 centimeter. That's 1 centimeter of width right there. So 10 of these pinkies would go across your hand, and that would be 1 decimeter. And then that brings us down to a millimeter. If I take this centimeter and I divide it up into 10 little bitty pieces, there's a centimeter right there. I divide it up into 10 little pieces, I get about the width of a dime is 1 millimeter. So there are 10 millimeters equaling 1 centimeter. 10 millimeters and 1 centimeter. So there'd be 100 millimeters in a decimeter. And of course there's 1,000 millimeters in a meter. And the word milli means 1,000. So 1,000th of a meter equals 1 millimeter. So therefore 1 meter equals 1,000 millimeters. So it's important to keep all these kind of straight in our mind. It can be somewhat difficult. We're talking about milli. I'd like to go on a little bit further from millimeters. If we go down now, we're jumping by 1,000. So 10 to the minus 6 power would be 0.000001. So this order of magnitude, we call this order of magnitude, this exponent, is basically how many places behind the decimal point we have. There's 1, 2, 3, 4, 5, 6. So 10 to the minus 6 is 6 places behind the decimal. This actually means 1 over 1 million. This is 1 millionth. A micro, which by the way is a fancy Greek symbol called a mu. Looks like an M, it looks like a U, we call it a mu. A micrometer is 1 millionth of a meter. A micrometer is 1 millionth of a meter. And so if we look at things that are on the order of micrometers, sometimes we call these, instead of micrometers or micrometers, we call them microns. So we can measure how many microns there are. So now we're down to things that are really, really tiny, and we have to use a nice, very, very powerful microscope to see some of these things. So here we have a this is a human hair actually, and human hair is somewhere usually between 40 and 50 microns or micrometers, 40 and 50 micrometers thick. So this is a human hair. There's an example of that. These here, if you're in biology, you might recognize these. These are red blood cells. Red blood cells. And red blood cells are smaller than the width of hair. They're about 6 to 10 micrometers, 6 to 10 micrometers distance across these red blood cells. And then down here we have some bacteria. Some pictures of bacteria. And bacteria are usually about 5 to 20 microns, 5 to 20 micrometers in length across them. So I thought it'd be kind of some interesting pictures there when we're talking about micrometers or microns. Okay, so let's go down one more even. Let's go. So this is a micro here is a millionth, right there. That's 1 millionth. This one's 10 to the minus 9, 3 more zeros behind the decimal. So this nanometer is a billionth. So let's look at nanometer stuff. Let's go even smaller, down to nanometers. So here we have these are viruses. It's a virus, and viruses are somewhere about 30 to 50 nanometers across. 30 to 50 nanometers across. Pretty small. You might recognize this if you're a biology student. This is a DNA, and DNA is a thickness of about 2.5 nanometers. Pretty small across it. So these are nanometers. These are 1 billionth, 10 to the minus 9, 1 billionth of a meter. There are 1 billion, which would be 9 zeros, 1 billion nanometers in a meter stick. So we're talking really, really small right here. If we go down, we could go down another 1,000, which would be we're at 1 billion right now. We go down to 1 trillion. We'd have something called a picometer. But I'm not going to go down that far. I want to go just actually one place down below nanometers. And that prefix isn't on here, but I do want to talk about it. So let's go to that one. And so what we're going to be at is we're going to be right in here. And this would be 10 to the minus 10. Or 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And this is called an angstrom. 1 angstrom. And the symbol for that is like an A with a little dot over the top of it. 1 angstrom. And the reason I want to mention this is because when we get down to an angstrom, we are on the size of the diameter of an atom. These are pictures of atoms on a surface here. Very, 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 very small. And atoms are like 0.1 to 0.3 nanometers. So this is 1/10 to 3/10 of a nanometer. So what's 1/10 of a nanometer? 1/10 of a nanometer would be 1 unit down below the nanometer, so that's what's called an angstrom. So a lot of times we have the terms of the atoms in terms of nanometers. 1 angstrom or 1 nanometer to 3 nanometers, but we can, or I guess it'd be 1/10 to 3/10 of a nanometer is an angstrom. And so I wanted to kind of get this because when we get down to the size of a atoms, like we're talking about in chemistry, we're talking about an angstrom, which is basically, this is a nanometer is a billionth of a meter. So an angstrom would be 10 billionth of a meter. So an atom would be about 10 billionth of a meter stick wide, which is clearly pretty small. So, and that's not on our list there, but right in there, right below nano, we'll go 10 to the minus 10 power. That's an angstrom. And that brings us then to the kind of question I wanted to ask. And we'll look at this question. It says, if you take a meter stick and divide it into 10 equal pieces, and then take one of those pieces and repeat this process, how many times do you have to do this until you are on the level of an atom? This is a really good question to ask people to see if they understand scales of the metric system. If I take a meter stick and I divide it up into 10 pieces, well, if I do that, so right here I'm going to start with a meter, so I'm right here. If I take that and I divide it up into 10 pieces, what would one of those pieces be called? Well, it would be this one right here. It would be a decimeter. And so here's part of the meter stick. If I divide it up into 10 pieces, here's 90 to the 100. That right there, that distance there, would be 1 decimeter. So that's one time. I've done it one time. I've done it one time, and I'm at a decimeter, or 10 to the minus 1. Okay, let's do it again. So we take a decimeter, we divide it up into 10 pieces, and I would go from 90 to the 91. And what's that distance called? Well, that distance is the next one down. It would be called a centimeter. And that's 10 to the minus 2. And so I've done this process now 2 times, and I was at a meter, and now I've done the process 2 times, and I'm to basically to the width of the pinky. So I'm getting pretty small pretty fast. I've only done it twice. So let's do it a third time, because what do we have to get to? We have to get to the size of an atom. What's an atom? An atom is around the size of an angstrom, which, if you remember, is 10 to the minus 10 billionth of a meter. So a lot of times people will say that you have to do, you'll probably have to do this process like 10 billion times. Well, let's just look at the evidence here. We've done it twice, and now we're down to the centimeter, 10 to the minus 2, a centimeter. Let's do it one more time. Let's take a centimeter and divide up into 10 little pieces, and that would be this right here, which is the width of a dime, and that's a millimeter, or milli, which is 1,000th, or 10 to the minus 3. We've done it 3 times, and we're already down to the width of a dime. So we're getting really small, really, really fast. And you might notice a pattern here. If we have done it 3 times and we're down to a millimeter, and the order of magnitude, 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, then how many times are we going to have to do this until we get down to an angstrom, which is right down here, and is 10 to the minus 10? Well, it's not as many times as you would think, is it? It's only 10 times. We would only have to do this process 10 times to get down from a meter stick down to the size of an atom. We did it 1 time, we're at a decimeter. We did it 2 times, we're at a centimeter, the width of a pinky. We did it 3 times, we're at a millimeter. We do it 4 times, or 5 times, or 6 times, because we're dropping by 1,000 now, 6 times, and we're already down to a micrometer, or a micron, which is incredibly small. So we're talking like, a red blood cell is bigger than a micrometer, and we've only done this process 6 times. So all we'd have to do is do it 10 times, and we would get down to the size of an atom. So I hope that helps with the metric system to kind of keep these track. You really need to know, how many things. If I say 1 kilometer, and I want to know how many meters that is, you need to know that that kilo there means 1,000. And so that you can write it correctly, that a kilometer equals 1,000 meters. And so you need to know the process of how that these all go up by tens. And later on, we'll do some conversion problems, some dimensional analysis problems, and hopefully this will make those problems a whole lot easier.